If you have a geometric series, then the sum of it is this. But let's say you had a infinite amount of terms, which is just another way of saying that you have the sum of n terms, but then you're taking the limit as n goes towards infinity. And it turns out there's going to be a formula for that. Now, that formula is only going to work if the absolute value of your r is less than 1. So, for instance, let's say you had something like 1 plus 1/2 plus 1/4, da 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 da. That's going to have a limit. But in case you had something like 1 plus 2 plus 4 plus da 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 da, then that will not have a limit because your r for that one would be 2, and of course the absolute value of 2 is not less than 1. That's not true. But here our r value is equal to 1/2, and the absolute value of that, of course, is less than 1. And what we can do is start off by just writing down that S infinity should equal the limit of Sn. Well, here's our Sn, the sum of the first n terms. So we can say that this is equal to the limit as n goes towards infinity of this formula right here. But the only place that we actually see n is right here. So let's consider the example where r is 1/2. If r is 1/2, then let's try to figure out what happens to 1/2 to the n. So if n is getting bigger and bigger, we can try to figure out what's going on. Let's start off by just going to a calculator and typing in only 1/2 to the 1. And then if we want it to be 1/2 to the 2, then we would multiply that by 1/2, and then you would keep multiplying by 1/2. And if you keep doing that, you're going to notice that you're going to get closer and closer and closer and closer and closer to 0. In fact, you start needing scientific notation for certain kinds of calculators. So this thing is heading towards 0, and it turns out as long as the absolute value of r is less than 1, well then this entire thing will head towards 0. So if that's true, what you would be left with is a1 times 1 minus 0 over 1 minus r, which would just be a1 over 1 minus r. So that is the sum of an infinite amount of terms. Now you can't really take the sum of an infinite amount of terms. What you can say though is that it's a limit of what the sum of the first n terms would be as n starts to get bigger and bigger and bigger. So if we use this example right over here where we have 1 and then 1/2 and then 1/4, well, our first term would be 1, and our common ratio is 1/2. And if you calculate that, that's going to be 1 over 1/2, which is going to end up being 2. So that's your limit here. And when you have the limit of a series, we say that it converges. So we would say that the sum converges to 2. That doesn't mean you're ever going to actually hit 2. You'll get as close to 2 from below 2 as you could possibly want, but you'll never actually get to 2. And you can use sigma notation. Let's say you want to do it on Desmos. Well, then you just type in SUM, and it starts with sigma notation. And we're going to do the sum from 1 to, let's say we just want to do only maybe the first 3 terms. We'll raise that number gradually. But then we need to put the formula for a geometric sequence. And that formula is a1, which in this case is 1 times r, which in this case is 1/2, raised to the n minus 1. So you just got to put parentheses around this exponent here. And now it gets you the sum of the first three terms, which would be 1 plus 1/2 plus 1/4. But let's say I wanted to do a higher amount of terms. Let's say I wanted to do 4 terms. Well, okay, it's getting closer to 2 now. If I do 5, it's getting even closer to 2. Let's say I were to do 50. Now it actually says it is 2. Now it's not actually 2, it's just rounding. But let's say you did something like 10, you can see that you're getting very close to 2. We can go to OpenStax here in their Calc 2 textbook, link is in the description, and we can see that they're kind of summarizing this for us. They're saying that a geometric series is a series of the form where you start off with a times r to the n minus 1, and the notation that you could use is a1 here, but you don't really have to. Sometimes people will just put a, and then times r to the n minus 1. So that's the same thing as writing s infinity. Now we could then say that the geometric series test is that the absolute value of your r needs to be less than 1, and if so, your series converges. In other words, the limit exists. And if the absolute value of your r is greater than or equal to 1, well, then that means your series diverges, which means that the limit does not exist. So just an example of where it would diverge, if you did something like 1 plus 2 plus 4 plus 8, that is clearly not going to have a limit. That is just going to shoot off towards infinity, so definitely not converging to a number like 2 or whatever. Okay, and last thing over here is not only do we know it converges, we know what it converges to. There's actually a formula for this one. Now that usually will not be the case as we continue to do other types of series tests where we will only be able to say whether something converges, not what it converges to. We usually won't have a formula for that. And now this video is over.